Next up, I'll go to -1. According to that, I had a value of 1/2, so go to -1 and up only about halfway. Here I'm going to start getting a little close to the line. And then for -2, I'll have a value of 1/4. So at that point, it's barely sitting above the line. Now, let's see. I think we could possibly go a little further still. Let's go ahead. Let's figure out our value for -3. So at -3, that means that f of that for f of x, I'm going to look for f of -3, which is just going to be 2 to the -3. Okay. Think about that for a sec. That's just going to be equal to 1/8. It's 1 over 2 to the 3. So I get 1/8. Now we're getting extra small there. So try to plot that. Basically going to probably just try to set that one right just above the line. And as we keep going, our denominator here is just going to keep doubling. So next up I'll have 1/16. After that 1/32. So it just keeps getting closer and closer to the line. But it's never actually going to cross. Alright? And what I want us to do here is I want us to say, okay, this line that our function's never going to cross, we're going to call that asymptote. Okay. So we call this thing an asymptote. And there's a lot of fun that can be said about that. I know it's probably a funny word, so I'm going to let you guys kind of get your giggles out. Asymptote. Now, what's funny about these, there's all kinds of fun jokes, you cannot touch the asymptote when you're making a graph. Your function can get close, but it cannot touch. Alright? So, with that, there's one of our terms. And with that, we're going to pick up a couple other vocabulary terms as we go throughout today. But that is our first thing. So with these, we're going to have to sometimes determine where's our asymptote. In this case, it just happened to fall right along the line y equals 0. Put that up on the screen there. In this case, our asymptote was just right along that line y equals 0, or right along the x-axis. Sometimes we'll have to determine its place, and it'll be somewhere different than y equals 0. Let's take a different function. And we're always going to start off by just making a table of values and determining just a handful of points. This time, let's try something like y equals 3 to the x. We'll change the base from 2 to 3. And this time I'm going to add just one extra element to the mix. We'll just say that we're going to add 2 for whatever reason. Alright. So, I'll start off here and I'll say, let's start by looking for maybe f of 3. Look for f of 2. F of 1. Okay, we'll go as far down as, let's make it -3. Okay. So, just a quick reminder here, again, because function notation, we haven't had this for a while, so we'll look at it. In this case, when I'm looking for this new f of x, which, again, we should call that an f of x rather than y, as I'm looking for a new f of x, this time it's going to be 3 to whatever we're looking for, 3 to the x, 3 to the 3. And then don't forget to add the 2 at the very end there. So now for this new f of x, wherever there was an x, we'll put in our new value. And again, this is going to simplify to 3 times itself 3 times. Then we'll add a 2. And that's going to give us 3 times itself 3 times will be 27. plus 2 gives us a value of 29. Alright. I'm going to let there be a little moment here where the video can be paused. I want you to try this out for a little bit on your own. I'm assuming that's all happened. Welcome back. Alright. So for f of 2, we got 3 squared plus 2, which is equal to 3 times 3 plus 2, which will give us 11. For f of 1, that's just 3 to the 1 plus 2, which 3 plus 2 just gives us 5. Alright. F of 0, it's going to be 3 to the 0 plus 2, which, for this one, just a quick friendly reminder, anything to the 0 power, that's just 1, plus 2 will give us 3.